For centuries, stargazers have been captivated by one of the most enigmatic and luminous celestial bodies in the night sky, a star unlike any other, Betelgeuse. Located in the shoulder of the Orion constellation, this red supergiant, with a diameter over 700 times that of our Sun and a mass approximately 20 times solar, has long been a subject of fascination and concern for astronomers worldwide. For decades, scientists have been monitoring Betelgeuse as it swelled, dimmed and erupted, its instability a constant reminder of the unpredictable nature of the cosmos. In 2019, the star suddenly faded, sparking global speculation. Was this the long-awaited supernova? Now, with the James Webb Space Telescope, JWST, capturing the unprecedented, astronomers have their answer. What the JWST has observed is nothing short of breathtaking. For the first time, we're witnessing real-time indicators of a star on the brink of collapse, with massive energy discharges, shifting surface convection, and magnetic fields twisting into chaos. Betelgeuse isn't just dying, it's transforming right before our eyes. The JWST has been focused on Betelgeuse for months, using its infrared vision to peer into layers previously invisible to any observatory. The data collected is stunning, revealing convective bubbles the size of Jupiter bursting on the surface, plumes of hot gas streaming into space at unimaginable speed, and hidden within the light spectrum, a shockwave moving through the star's outer layers. This isn't just another deep space observation, this is a once-in-a-lifetime event. The closest supernova humanity has ever recorded. The explosion of Betelgeuse will eventually be so bright. It could be visible during the day, brighter than the full moon, but its proximity offers more than just a spectacle. It provides scientists with a once-in-a-generation opportunity to study the death of a star up close. By observing the actual physics of a star tearing itself apart, astronomers will gain insights into the process that creates the ingredients for life, the same elements that formed Earth and us. We are witnessing our cosmic ancestry in reverse, from the fiery collapse to the raw materials of creation. But the explosion of Betelgeuse isn't just a cosmic spectacle, it's a key, unlocking the hidden processes behind galaxy formation, planetary systems, and the cycle of life in the universe. Through the JWST's advanced instruments, we can now model the final stages of stellar evolution with unmatched precision. We can finally understand what happens inside a star as it dies, and we may even learn what signals to look for in others, possibly predicting future supernovae long before they happen. The explosion of Betelgeuse is more than a spectacle. It sends shockwaves across light years, disturbing the surrounding interstellar medium. Already, the JWST has detected the early ripples, high-energy particles moving outward, heating surrounding gas clouds and altering the shape of the star's dust halo. But there's something else, a gravitational shift. Even from 642 light-years away, the collapse of Betelgeuse's core may have sent out gravitational waves, the kind we've only just begun to detect. If confirmed, this would mark the first time we've linked a visible supernova with direct gravitational data, and that would rewrite everything we know about the interaction between light, matter, and space-time. As Betelgeuse collapses, one of the greatest cosmic questions re-emerges. What's left behind? A neutron star, a black hole, or something stranger? The data from the JWST suggests that Betelgeuse's collapse may not be entirely uniform, with magnetic field disruptions, plasma voids, and a possible asymmetric fallback. Some astrophysicists are even speculating about a transitional object, a phenomenon that sits between a neutron star and black hole, theorized but never observed. If the JWST has caught this in action, It would be the first direct evidence of a new class of cosmic object. With a star exploding just 642 light-years away, many have asked, are we in danger? The short answer is no, Betelgeuse isn't close enough to harm Earth, but the longer answer is more complex. The explosion will release a wave of high-energy particles, gamma radiation, and expanding electromagnetic bursts. These could potentially disrupt cosmic dust clouds, influence other star systems, even trigger changes in how light from other regions reaches us. For now, the JWST is closely monitoring the velocity and spread of this radiation front, because even if we're safe, the explosion may alter the optical structure of our galactic neighborhood, changing how we observe the universe from here on out. Betelgeuse is massive, ancient, powerful, and yet it's dying, a reminder that even stars, those eternal lights in our sky, have limits. What the JWST has captured isn't just the death of a star, it's a cosmic mirror held up to us. Everything that lives ends. But in that end, new elements are born. New stars will rise from Betelgeuse's ashes. New worlds may form in the chaos it leaves behind. This is not destruction, this is cosmic renewal, and we were lucky enough to witness it. Among the vast data collected by the JWST, scientists discovered something unexpected: variations in the elemental composition of the ejected material. The explosion of Betelgeuse is releasing not just carbon, oxygen, and iron, but rare elements like technetium and yttrium, formed only in extreme stellar environments. By analyzing the ratios of these elements, scientists can trace the life cycle of matter in our galaxy, from the core of dying stars to the dust that forms planets, to the atoms inside us. The JWST isn't just recording an explosion, it's decoding the chemical script of how life becomes possible. As we bear witness to the death of Betelgeuse, we're reminded that our sun too will one day fade. But from this ending comes the blueprint for everything new. Without supernovae, there are no planets, no oceans, no life. And now, thanks to the JWST, we can finally witness that full cycle, from fiery collapse to the raw materials of creation. In the cold silence of space, 642 light-years from Earth, a star has ended its life, not with a whisper, but with a brilliant, final roar that travelled through the dark for centuries until it reached us. Thanks to the James Webb Space Telescope, we didn't just see it, we understood it. We saw the signs, the collapse, the detonation, not as myth, not as metaphor, but as fact. Betelgeuse didn't die in vain. In its final moment, it gave us answers to questions older than humanity itself. Where do the elements come from? How do stars live and die? And what will happen to our own sun? In that fading red light, the JWST has captured more than a supernova. It captured our origin story and a glimpse of our future. So now we ask, what else is the universe ready to show us? And are we truly prepared to witness it? Let us know what you think in the comments. Was this the most important stellar event of our time? And what will be the next cosmic secret the James Webb Telescope reveals? Subscribe and turn on notifications, because this isn't the end. It's the beginning of what comes after the stars.